Alright, here we are at the second part of our videos about digital logic. This one we're going to introduce what's called a truth table, or truth tables, for these various digital gates, alright, logic gates. So, and then we're going to interpret basically the inputs and outputs in terms of zeros and ones. Remember that a 0 means off, a 1 means on. Alternatively, 0 can mean low and 1 would mean high. So in the case of the NOT gate or the inverter, it has a very simple truth table. We have a column here for input A, a column here for output Y. And so if you've got an input of 0, you get an output of 1. If you have an input of 1, you get an output of 0. So this truth table shows you exactly what's happening with this logic gate. So if your input is high, your output is low. If your input is low, your output is high. So 0 in, 1 out, 1 in, 0 out. Okay, so that's it for the NOT gate. Let's look at the other 4 gates. Now the truth table gets a little bit more complicated because we have 2 inputs and 1 output. So basically we have to do all 4 combinations of how the inputs can be, 0, 1, 0, 1, and then what happens to your Y. So there will be 4 situations for output Y and 2 situations for A and B both. So that's what's going on here. If B is 0 and A is 0, then Y is 0. That's how you interpret this. So A is 0, B is 0, Y is 0, that part of the table. All right. If B is 1 and A is 0, then the output is 0. If A is 1 and B is 0, then the output is 0. Then if A is 1 and B is 1, the output is 1. Alright, so that's what's going on. Here is the truth table of interest right there. If A is 0, the output is 0. If B is 0, the output is 0. The only time that the output of an AND gate is 1 is if both inputs are 1, and that's shown here on this truth table. Okay, you should remember that from our previous video, but now you can see it visually with these zeros and ones. And now we're going to go through the OR gate. Alright, so again, here's our inputs. This is the symbol for the OR gate, and there's the output Y. So again, we have the same type of a truth table here, but of course it's different in the outputs because this is an OR gate, not an AND gate. Alright, so if A happens to be 0 and B happens to be 0, then the output of Y is 0. If A is on, the output is on. If B is on, the output is on. So if A or B or both are 1, then the output is 1. And that's what this truth table shows you here in this part. Okay? I know this is really basic. It seems really basic and straightforward, but the things that we're going to do with this in the third video, I'll show you just a little bit of what we can do with this, and we'll do a lot more in class with practicing and doing practice problems. But this has a lot of power to do really interesting things in digital circuits, especially in control circuits if you add sensors and things like that. All right, let's do the last 2 gates. Here we have the NAND gate. So again, we've got an AND gate with the little circle at the end. 2 inputs, A and B, output Y. So if A is 0 and B is 0, then the output is 1. If A is 0 and B is 1, output is 1. If B is 0 and A is 1, then the output is also 1. But if A is 1 and B is 1, then the output is 0. This is the exact opposite. This truth table is exactly opposite to the AND gate, because a NAND gate, of course, is an inverted AND gate. All right? So you can rewind a bit if you want to look back at the AND gate truth table. You would see that every spot where there's a 1 here, there is a 0 for the AND gate, and then this spot, which is a 0, would be a 1 for the AND gate. So this is exactly opposite of the AND gate. All right. Lastly, we have the NOR gate, which is exactly opposite to the OR gate. If you remember, the OR gate is always on, it's always 1, except in the situation where both inputs are 0. This one's exactly the opposite. This one is only 1 in the situation where both inputs are 0, so that's here. If A is 0 and B is 0, then the NOR gate has an output of 1. If either of the gates is on, or value of 1, then the output of the NOR gate is off, or 0. Alright, so that's shown here. If A is on, value of 1, then the output is 0. If B is on, value of 1, the output is 0. If both of them are off, that's the only time that the output is on. So these gates then lend themselves to being used in specific situations where you need very specific inputs to produce a certain output only, right? So we're going to look at more detail of how exactly that works in a control circuit in the next video. So this one has been basically just about truth tables for the 5 gates, and hopefully solidifying your concept of how they work. In the next video, I will show you some examples of how they're used in actual control circuits that do real things in the real world. So that's it for this video. Not too long. Thanks for watching, and we'll see you next time.